If you're a regular subscriber of mine or follow my videos, you'll know that I recently had to replace one of the rechargeable batteries on this Ryobi cordless drill. The battery pack in question is this P102 battery pack. And what ended up happening was this battery would no longer take a charge for some reason. The charger recognized it as being defective. And my immediate reaction was to call Ryobi and get a replacement battery, since the drill was only about 8 months old, and I know the batteries are warranted for 3 years. I was able to get a replacement battery from Ryobi under the warranty with no questions and no hassle. They just shipped me out a new one. And what I found most surprising was that they didn't ask me to ship the old one back. They told me to just recycle it. So I started thinking about this battery today. This battery is only a few months old, and I find it hard to believe that it's completely shot already. So I'm starting to suspect that maybe there's a way that I can bring this thing back to life and have a fully functioning battery again. So I really don't know a whole lot about lithium-ion battery technology. I started thinking about this today, and I thought that, you know, inside this battery pack there's obviously going to be batteries, but maybe there's a control board in here that for whatever reason is not allowing the battery to be charged. And I'm presuming what happened is that the batteries, the individual cells, maybe one or all of them, has dipped below some sort of a minimum voltage, and the board inside is preventing the charger from recognizing it anymore to help prevent any fires or anything like that. So the first thing that I'm going to do before I take anything apart here is I'm just going to do a quick voltage check and make sure that I've first of all got the right battery, because I've now got 3 of these that all look the same, and I didn't mark the bad one here. But you can see on the voltmeter there, if my hand's out of the way enough, that this thing is reading 0.068, 0.067 volts, so it's pretty well depleted. So in order to get this thing apart, it's got these safety Torx screws on it. So in order to get this battery apart, I'm going to have to remove 4 or 5 screws. So this is a regular Torx head screw. I think it's a T10 size just from looking at it. But it's got a protrusion in the center of the Torx pattern, which requires a bit that has a hole in it. I don't know exactly why they do this, if it's some sort of safety measure because they think that people don't have the bit readily available to take that off, but you can buy them at pretty much any hardware store, so it's not really all that much of a safety device or anti-tamper device, but I guess it's better than nothing. Okay, so I'm not sure if that's completely in focus or not, but there's my T10 with the hole in the end of it bit. I'm too lazy to go all the way upstairs and get my proper driver for one of these, but I'm just going to use this 1/4-inch driver, and that ought to be good enough to get at these screws here. So I'll take these screws out and then come back and show you guys what it looks like inside. The screws holding the battery together are located here, here, here. There's one in the middle, and then there's one here underneath this anti-tamper plug. I should be able to just pry this anti-tamper plug out, but doing so is going to void any warranties or anything like that. So if you're going to attempt to do something like this, keep that in mind, that once you pull that plug out, you're voiding your warranty. So I've got all of the screws removed. Pull this out, and you can see what it looks like inside. So now it looks like I can just pull the battery pack out of the plastic case here. I just want to be careful that I don't rip anything apart, but it looks like it just comes out. It's not screwed in or anything. So here's the batteries on the bottom. It looks like some sort of regulators here and the main control board here. So a quick visual inspection. I don't see anything visually wrong. No parts look to be burnt or anything like that. I don't see any cracks or signs of damage, which, you know, I wouldn't expect. So I've got the meter here, and I think what I want to do now is do some voltage tests on the battery pack itself, bypassing the stock that has the contacts in it that would go into the charger or the drill, because these are connected into the circuit board, and I may be getting, kind of a false reading, so to speak, because the board may be shutting the batteries off. And it looks like if I just touch these contacts here, there's one down here that looks to be the positive contact, and this one up here on the opposite corner is the negative contact, I believe. So if I just check the voltage directly from those contacts, I should be bypassing the board and getting an idea of what the true voltage is on this thing right now. And you can see there it's reading about 5 volts. So there is a little bit of life in these batteries, and when I check here, you can see that the board, for whatever reason, is just keeping that right down at almost 0. Probably, like I said before, as a safety measure. So now, what I'm thinking is if I just try and somehow get a charge into this battery by touching the battery terminals over here with a power source, maybe I can inject enough voltage into the batteries temporarily to raise it above the threshold where the circuit board shuts off the charging ability. So I've put the battery pack back in the bottom half of the case just for convenience sake. So a couple of ideas come to mind on how to try and get a little boost charge in these batteries, so to speak. Now my first thought is to use this power supply that I have over here. This is just a regular 10 amp, sort of call it a ham radio service type power supply. And I could try and just touch its leads to the appropriate leads on the battery pack and see if that would give this thing a kick. But I started thinking about this a bit, and I'm wondering if I could use the charger that came with it. And the only reason I'm thinking of trying this is because probably most people watching this video aren't going to have a power supply like that. You may be able to see inside the charger here, but there are 3 spring contacts here. One over here on this side is the positive, one on this side is the negative, and this one I believe is sort of a sense port. As you can see, this thing can charge NiCads, lithiums, and lithium plus. Assuming that this tab is being used to sense the battery type and allow the charger to, adjust its charging behavior accordingly. Okay, so I'm going to attach these jumper wires to the battery charger first. And just for the sake of trying to be somewhat careful, I'm going to unplug the battery charger first. And I'm going to put these on here. And I want to make sure that I don't touch these leads together or touch them to anything that they shouldn't be touched to. Now I've got a red one for the positive side, and I'm going to use this green one for the negative side. I'd really rather use a black one, but I can't find my black one. And we'll try and use this white wire on the sense tab. So I've got my positive lead connected to the positive terminal on the battery, and I've got my 2 other leads. I've got my negative lead, the green one, and the sense lead, which is the white one. So now I'll just touch these to the negative terminal of the battery, and let's see what happens. So you can see the charger started blinking fast. Now the green light is going as if it's charging the battery. Now I'm going to stop there and see if there's any voltage in the battery. So I've got the meter back over here now. I'll put the negative lead over here, the positive lead here. Yeah, so I've got about 10.8 volts there. And you can see as I leave the meter on there, it slowly bleeds that charge off. So I'm going to do this charge process one more time. I'm going to try and get the battery up to about 14 volts or so. Try this again. And I don't want to go too crazy with that, so we'll do another quick voltage check here. And you can see I'm up to 12.7 volts now. So I think I want to get that a little bit higher. Try one more time here. And I've got 13.6. I'm going to try that. Okay, so I've got my clip leads out of the way there. And what I'm going to do is just drop the cover onto this battery. I've got that clipped in. I'm not going to put the screws in there just yet in case I don't have enough voltage in there and might have to take this apart again. Let me try this. It looks like everything's working the way that it should. So I'm going to leave this in here for now, and I'm going to see if it'll charge up. I'll keep an eye on it, make sure it doesn't get hot. It looks like this may be revived. So it's been about an hour or so. I haven't really been keeping track of time that closely. But you can see that the green light is on steady, which means the battery is most likely charged. So now I'll do a quick voltage check on the battery. And you can see I've got 19.4 volts or thereabouts. So this ought to work. So the real test now is to connect it to the drill, and let's see what happens. Well, there you go. It looks like that battery is now fully functional. So now it looks like all I have to do is reinsert these screws, and I've got a third fully functional battery thanks to Ryobi's warranty policy. If you found this video helpful, please give it a thumbs up. And if you'd like to leave a comment or subscribe, feel free to do that as well. Thanks for watching.